Well, let's tackle evaluating trigonometric functions given a point, and of course we're talking about here on the coordinate plane. This is eventually going to lead us to the unit circle. But here we see an example of what we're talking about. We've got this angle theta. This is marked by this red coming back down here to this terminal side. And then we have a point here on that terminal side. And it's got an x and a y coordinate. Now the x coordinate is going down the left side of the horizontal axis from the origin, so it's, in this case, it's going to be negative. And the y coordinate also negative because it's going below the horizontal axis along the vertical axis, but we do have an x and y coordinate. Now what we don't know at this point to find all the trig functions is we don't know what the measure is of this terminal side, and it's designated by the variable r. And again, this is all going to lead us to the unit circle. That's actually going to be a radius. That's why we do it r, but it's not telling us that at that point. But if we know the x and y coordinate, we can find the measure of r by using Pythagorean theorem. And then once we have that, then we can find all the trig functions. So now if this is theta and this is part here on this terminal side, well, if we're looking for the sine being the opposite over the hypotenuse, then it would be designated as this y coordinate over the hypotenuse. Hypotenuse, if we bring a dotted line down here, this is how we get that. We form a right angle, and that's going to give that value of r as the hypotenuse. And so it's opposite over the hypotenuse, or y over r, and the cosine is going to be the value of the x coordinate, the length of the adjacent side, adjacent to that angle, over the hypotenuse, x over r. And then we got the tangent with opposite TOA, opposite over the adjacent. It's the y coordinate over the x coordinate. And then our cosecant, secant, and cotangent functions are just the reciprocal of that. So let's move forward and see if we can't tackle ourselves a problem. So here we're told that the terminal side of theta in standard position contains the point 6, 2. Find the exact values of the 6 trig functions. Let's kind of just sketch a coordinate plane, if you will. Maybe I can make that a little bit straighter. And so we've got a point on the terminal side at where x is -6 and y is 2. Let's say maybe that's right about there. And so we've got, we've got a terminal side right here. And if we come down here with a dotted line, we form a right angle. All right, and so this is a right angle right here. And we're talking about theta coming here, and this coterminal right here. So we're going to say this is theta. All right, so then our sine, well, first we got to find the value of r. This is r. So we can use Pythagorean theorem so that r is going to equal the square root of negative 6 squared plus 2 squared. Remember Pythagorean, a squared plus b squared equals c squared. R, we're substituting r for c squared, and we're taking the square root of that. So let's see, negative 6 squared is 36, and 2 squared is 4. So now we're talking about the square root of 40. And we can simplify the square root of 40 as the square root of 4 times the square root of 10, which then is going to be r, we're going to say, is equal to 2 square root of 10. All right, so now let's think about the sine function. All right, so the sine function is going to be the opposite over the hypotenuse, so, and that is going to be the value of the x-coordinate. Excuse me, I think theta in this example is going to be up here. All right. So the x-coordinate over r, so I got, excuse me, the y-coordinate over r. I had it in the right place to begin with. I shouldn't have done that. Then we got sine is equal to y over r, and the y-coordinate is 2, and then we have said that the r is 2 square root of 10. Well, the 2's are going to cancel. That leaves me with 1 square root of 10. But mathematicians don't like that radical in the denominator, so we're going to rationalize it by multiplying this by the square root of 10 over the square root of 10. And then once we do, we end up with the sine being the square root of 10 over 10. 10 times 10 is 100. Square root of 100 is 10. So there's our sine. Let's see, our cosine is going to be the x-coordinate over the radius. And the x-coordinate is negative 6. So we got negative 6 over 2 square root of 10. Well, that can simplify to negative 3 square root of 10. And again, we're going to rationalize this by multiplying it by the square root of 10 over the square root of 10. And that's going to then now be negative 3 square root of 10 over 10. What about our tangent? Well, our tangent is equal to y over x, opposite over adjacent. And let's see, so our y-coordinate then is 2, our x-coordinate is negative 6, and that can simplify down to negative 1/3. All right, I think I got room to get the other 3 in. The cosecant is the reciprocal of the sine. So right here, I had it simplified to 1 over the square root of 10 before I rationalized it. So the cosecant is just equal to the square root of 10. How about the secant? Well, the secant is the reciprocal of the cosine. And right here, we had it before we rationalized it. We had negative 3 square root of 10. So the reciprocal of that is the square root of negative 10 over negative 3. And let's see, what else have we got? We got the cotangent. And the cotangent is the reciprocal of the tangent. Well, there's the tangent, negative 1/3. So the cotangent is equal to negative 3. You definitely want to do some practice here. Practice, practice, practice. And do it with patience. And then you shall succeed.